guys want me to start? Yeah. All right. Welcome back, PowerShell Conference Asia. That was a good talk from Jeffrey, right? Yeah, good stuff. Now, just to kind of underscore some of what Jeffrey was saying about the importance of digital transformation and DevOps, or I'm going to put a little regex there in just a second. But I was here a couple weeks ago with my close personal friend, Prime Minister Lee, doing a little talk around DevOps here at the GovStack Tech Conference. No, I'm just kidding. He's not a close personal friend. He barely tolerated standing next to me for a selfie. But I was told by some colleagues here that if I ever do talks in Singapore, I have to put this picture in my slide deck. So achievement unlocked, and let's move in. We're going to talk about site reliability engineering for a little bit. And so I said I was going to come back to that focus on DevOps. And what I would like to talk a little bit about is a kind of a related movement that kind of happened around the same time, and has some stuff in common with DevOps, has some stuff that's slightly different. But at the end of the day, both of those efforts lead us towards what's called high-performing IT, right? Who here has heard of the State of DevOps report, right? So if you haven't, there is an organization called DORA, the DevOps Research and Assessment Organization, and they've done, for a number of years, it was in conjunction with Puppet Labs. Now they've got a little broader, also a little broader group of sponsors. But they've done research over the past several years around what high-performance IT looks like. And a lot of the core concepts, when they drill down into what are the behaviors that lead towards high-performance IT, some of that stuff falls out into what we call DevOps. Some of it comes out into what we call site reliability engineering. And who here has heard of site reliability engineering? Who is a site? Anybody in SRE or that's in their job title somewhere? All right. So we're going to do a quick little level set. We're going to do like a little SRE 101 here. And what we're going to do is just kind of put some definitions around what site reliability engineering is, so that maybe you can decide, hey, is this something is this an area we want to invest in, or is this how we want to shape operations to look like? Or is this something that, seems like voodoo and magic and we don't want to touch this thing? So, first definition. So we're all starting from the same place. Site reliability engineering. It's an engineering discipline, that's key, right? That's devoted to helping an organization achieve the appropriate level of reliability in their systems, services, and products. Now, what would the key words in this be? Any guesses? There's two key words in this definition. Reliability, I've heard, yes?
Appropriate level is critical.
So appropriate and reliability, those are two key elements of this, in this definition. Anybody think that 100% reliability is our goal? Nobody. Good. Smart audience. Very often, if we talk about achieving 100% reliability, number one, it's not really a thing, or it's so expensive that it's way out of reach, right? But appropriate level, that means we have to have the right conversations with our, with our developers, with our business partners, with our customers to understand what the expectations are for reliability. And that then becomes one of the core focuses for site reliability engineering. All right, worked really hard on this slide. Actually, I stole this slide from one of my coworkers. He worked really hard on it. Anybody know what this slide is? The Beatles. No, yeah, No, this is actually this is what you get when a PHP application errors out. Or you might be more familiar with something like this, when a .NET application errors, or Java application. Now, I hesitate a little bit in sharing some of these different error screens because I know they can invoke a little bit of PTSD in some folks, right? We've all seen these, we've all kind of worried about them, and we've all been hiding from the consequences of these things coming up in front of customers or people up our management chain. So these are some of the situations that we try to avoid in the practice of site reliability engineering. So how did this all kind of come about? Well, very much like the conversation around DevOps, very much like that conversation that we hear, devs want to ship new features, ops doesn't want things to crash. What happens when we ship new features and we make changes to our environment? Things crash, they go down. It adds complexity, it adds risk into the environment. And so we've got this kind of tug of war happening. And this is the same tug of war that we talked about in the DevOps world. And to address this, Google was one of the first to kind of do this and talk about this. So that's kind of where some of this conversation started. But they approached it from a particular avenue of looking at site reliability engineering, where a lot of the industry approached it from kind of the DevOps talk. Now, what I'm bringing up site reliability and DevOps is slightly different things. One thing it is not is sometimes we see like these evolution kind of looking diagrams, and SRE is not the next evolution of DevOps. They both kind of came about around the same period of time to address the same sort of problems. They are complementary, they have some overlapping ideas, but they also have a few differing ideas. So both are valid approaches to improving the performance of our IT environments and therefore improving our quality of life as IT operations personnel. Now, one of the kind of where site reliability engineering was kind of introduced to the world at large was SRECon. SRECon is a conference dedicated to site reliability engineering. Funny how that works. You name it something, and that's kind of what it's focused on. It's like PSConf Asia. That's about Bash, right? No. What? It could be, as long as that Bash is running my PowerShell. And so at SRECon, Ben Traynor, who is the person who coined the term site reliability engineering at Google and built that practice there. And there he gave a talk, and he defined some of the things that he thought were elements of what makes up a site reliability engineer and a site reliability engineering team. And we're going to go through a few of the elements of that. Not everything, don't agree necessarily with everything that he laid out, but there's a lot of good stuff in there. And as site reliability engineering has spread from Google out to other organizations, that's opened room for more interpretation and for a different take on what site reliability engineering looks like. So, what does that actually look like? There's a lot of words on this slide. I do not expect you to go through and read all of these things, because we're going to pull out a couple of ones and talk about them more in depth. Now, one of the worrying things at the top there is just hire only coders, right? Who here writes PowerShell? All right, you qualify. So, with that out of the way, let's talk about a few specific things here. We're going to blank it out so you're not tempted to go read all the things. We're going to focus on, I think, some of the most important aspects that he called out, and that's having an SLA for your service, right? How do we actually say that things are reliable, right? We have to have some agreement as to what that reliability is. Then we have to make visible what that is. We have to measure and report on it. That means we have to have monitoring and metrics that show the things that we've agreed make us reliable, we're actually hitting those things, right? We can actually prove and show that. And we'll talk a little bit about what error budgets and things are here. But the kind of high-level idea is, if things are blowing up enough, we need to slow down and let things settle out so that we maintain our level of reliability before we go and break things again. One of the advantages of that, and we're going to talk a little bit more about this as we go through, is it keeps a focus on reliability. Yes, we want to deliver more features, but those features can't be at the cost of making that service unavailable, because if the service is unavailable, that feature doesn't help us any. When we start talking about SLAs, we talk about SLAs as kind of like the high-level agreement. When we start getting down into the weeds of things, we start talking about other, you'll hear a couple of other acronyms, SLI and SLO, Service Level Indicator and Service Level Objective. Those are how we measure our SLAs, and that's how we determine if we're within our error budget or not. So, blank screen. Animations. All right, so we start with our service level objective, right? So we have a service level agreement that says, hey, we're going to have this service available for X period of time. And for our service level objective, very often you'll hear people talking in terms of 9s. For all the examples I talk about here, we're going to talk about 8s because they're easier to, 80% is a lot easier to talk about than like 5 9s because people then start doing math in their heads and everyone gets a little wonky about that. So, because everybody comes up with a slightly different answer unless you pulled out your calculator or your phone and figured that all out, or unless this is some of that post-traumatic stress we talked about, and you've got these 5 9s and how much downtime that is kind of burned into your brain. So we're going to focus on 8s because I'll give you all the 8s you want of reliability, but we're going to focus on 80%. When we talk about examples here. So, we have our service level objective. That is, our service level objective is the threshold for our service level indicator. The service level indicator is the measure. So maybe my service level indicator is how many exceptions are being thrown by my application. Or maybe my indicator is the amount of non-200 responses from my application, or something to that effect. We define a service level of objective of not to exceed or to remain under a certain level of service level indicators. Over time, we have to monitor that, and if we exceed or go out of tolerance for our service level objective, we have to decide what to do. That's where having come to these agreements about our service level agreements ahead of time comes in really handy, because now we have exceeded this. How are we going to remedy that situation? Now it's not just an ops problem. Now it's a problem across ops and development and our business partners who rely on these new features to help deliver value out to our customers. So we take advantage of kind of formalizing this process to, number one, give us targets to shoot for, but number two, to bring everybody in alignment on the same goal. And that's one of the things we hear talked about in the DevOps space a lot, to one of the things that we hear talked about, now we're talking about with site reliability engineering, is bringing people together on the same goal. It's not about your org structure. It's about alignment on goals. So let's move it right along here. And is it good? Is it burning down? Yay. But when we get to that green condition, right, everything's easy. It's like, hey, if I was hitting 90% and my threshold was 80%, no problem. Let's keep shipping new features. Let's keep making changes. Let's evolve our architecture over time. But when we drop below 80 and we get to like 70% reliability on our service level objective, now we have to have those hard conversations. And the more we've talked about ahead of time, the easier those conversations get, right? And we always have the chance for, well, hey, in order to improve our reliability, we have to ship this new update because we just spent a cycle making our application better. Versus, well, I just refactored the whole application. It's a completely new code base, and it should be fine, right? We can have those conversations, and now we have some data to back them and to make a value judgment about whether or not we should go ahead with a release or not. So, observation number 1, right? Instrumenting our applications and environments. Number 1, help us come to agreement on what good looks like. But that agreement requires us to surface those metrics for people so that they can see them. We have to surface what those thresholds are so that they understand, and it brings everybody into this conversation. We create one of those feedback loops, and tying this back to DevOps and some of those complementary ideas, that's that second way from the Phoenix project, right, where we create feedback loops. Number 1 is we ship something. Number 2, we get that feedback loop, so we start getting that data about how it's performing and how it's behaving. So we're seeing that echoed here in this first set of practices around site reliability engineering. Kind of the next most important part of what I think comes out of Ben Trainor's description of site reliability engineering. And I apologize at the back if you can't see it. It's down toward the bottom. But we run postmortems for every event. Now, not every event, like, hey, Steve showed up to work today, better have a postmortem about that because that's unusual. That's not really what I mean. For every significant event, if we had an outage, if we had to gate builds because we fell through, we had our service level indicators dipped below our objective, right? We want to run a postmortem to figure out what went wrong, but not what people did wrong. The key to this is that we are blameless, right? That this is not a person's fault. It's a process and technology problem. What do we have to do to change our process? What do we have to do to change our technology to keep this from happening again? Why was Johnny able to type deploy software -- destroy the data center, right? That should never have been a command line switch on that utility, right? Or they should, right? We should have things, we should put things in place to keep it from, do you remember the British Airways data center outage from like a year and a half ago, right? Somebody turned off the wrong light switch or something like that, right? That should not be something, and it's like, well, yeah, it's this guy's fault for hitting the wrong switch. No, that one switch should never have been in the position to take out the whole data center. It's not the contractor's fault for hitting the wrong switch. It's the design of that infrastructure that was at fault there, right? So when we have these postmortems, and we should have them, and we should have them regularly, and do people remember a little Azure outage that happened at the beginning of September? Right? There's some good postmortem stuff, both from the Azure DevOps team and as well as from some of the Azure teams around what happened with that. You know, in that case, it wasn't necessarily a people problem because lightning came and hit a data center. That's usually a little bit out of people's control. But force them to look at what are our process decisions around deciding to fail over. And can we fail over safely within the tolerances that we expected? Because they decided, in the case of Azure DevOps, that we were not going to fail over because there would have been data loss. And so why would there have been data loss? Let's look at that. Let's look at the process of how we protect the data. Let's look at the process of how our failover operates and what our tolerances for data loss are. And make sure that next time something like this happens, we're not in the same position. This leads us to observation number 2. We can't fire our way to reliable. Right? Who here has worked in an environment where during an outage you had VPs or so stalking the halls looking for someone to blame? I have. Right? Who's not on the conference bridge? Right? Why aren't you on there? And then you're on the conference bridge, and it's like, so what are you doing to resolve the problem? I'm sitting here talking to you, and that whole just dysfunctional environment that is so painful to live in, right? That is not a way to improve our IT experience, right? So, number one, trying to fire your way to reliable gets rid of the people who probably have a good chance of helping make your systems more reliable, but also addresses the wrong problem. Remember, it's not a people problem, it's a process and technology problem. When you start trying to fire your way to reliable, people figure out ways to point to somebody else. And the focus is more on covering and obfuscating the work that you did and hoping somebody else has that problem land on them. That does not engender a lot of great camaraderie on your team, right? So we don't want to try to fire our way to reliable. So we've talked about monitoring. We've talked about postmortems. So what happens in between those things, right? How does our day-to-day workflow if we are trying to work as an SRE or site reliability engineer? One of the kind of the core ideas here is that we try to focus. We try to focus on making sure that there is room for project work to improve our environments. How many times have you heard, "I'm too busy to do X"? Who said that ever? And you can replace X for whatever project, right? It could be a monitoring project. It could be making our VM deployment more reliable. Whatever that project is, right? I'm too busy fighting fires, or I'm too busy doing tickets, or I'm too busy doing else. If we don't make space for that project work to make our systems more reliable, then we're pretty much living in that environment where not only are we fighting the fires, but we're causing the fires, because we're just letting our technical debt build up and build up and build up. Right? So one of the tenets around site reliability engineering is that when we cross over 50% of that manual, like ticket-driven or toil-type work, toil is one way that we kind of can refer to this, is anything over that falls back to the dev team. Now, this is not something that you just go back to work and say, okay, guess what, guys? We're going to be SREs, and I'm going to stop working on tickets after I spend half my day on that, and you guys can go pick up where I left off. That's not going to go well for you, right? This is something that has to be approached at an organizational level. You need strong management support for investing in this type of capability, in this type of agreement, right? But we also focus on on-call and making sure that the on-call experience is not horrible. There are medical studies out there that show how bad on-call experiences can be, right? So they target at least 8 people on a team so that you can spread the on-call responsibilities around enough, right? And you want to see a maximum of 2 events per on-call shift. Now, these are just numbers that they picked because that was their scenario. Same thing with the 50%. These numbers are all negotiable. And they're going to vary based on the environment that you work in, right? A lot depends on what that on-call rotation period is. If you're on call for a week, 2 events may or may not be reasonable. It depends on your environment. It depends on the environment that you're supporting. So the thing we have to remember is that people build systems. We have to take care of people because burned out, tired, scared people do not build reliable systems. So if we try to fire our way to reliability, if we're burning them out on being paged at 2 in the morning, day after day after day, and if we are burying them in ticket work during the day, so they're up all night fighting fires, and then they're doing this manual, repetitive work during the day, their spare capacity for building quality, reliable systems drops to next to nothing. So we want to keep an eye. We want to make sure that we value the efforts our people have, and we want to build systems to protect our people over time. So we have just done and gone through a basic SRE 101. Congratulations. You all passed. Now I want to talk a little bit about some different organizations that implement site reliability engineering practices. We start with Google because that's where kind of a lot of this concept started, and there's a book out there. I'll show you all a couple of books in the space as we get to the end that defines a lot of this. But for a while, Google didn't talk about what they were doing because they figured it was kind of like their secret sauce. Well, that's obviously changed. Now there's books and conferences and podcasts and newsletters and all sorts of stuff around site reliability engineering. And it's good because we're sharing information in the ecosystem. And that's another one of those like nice little DevOps tie-ins, right? Sharing. So how does Google implement site reliability engineering? Well, they have a centralized career ladder, and they partner with teams. So like you have SREs for Gmail, and you have SREs for Maps, and you have SREs for, well, you had SREs for Google Reader, and then it went away. Still bitter, a little bitter, still bitter. But then they also split those teams in a geo-distributed way so that you have coverage over all the time zones, right? It's one of the things I like about coming here is I get kind of refreshed on, hey, you know what? There are more time zones than just Central Time and Pacific Time, right? And so, like I was able to, this morning before I came out here, I was able to read my son a bedtime story. And he's like, go, and he gets time zones because he's like, go have a good day at your conference, Dad. I'm like, okay, sleep well and have a good day at school tomorrow. But, right, so we have geodiversity in teams there. I'm saying we, not at Google, so it's not really a we, but I just happen to say that. All right. Site reliability engineers at Google are a scarce resource. Teams have to lobby for them. They have to show that their service needs site reliability engineers and it's mature enough that it's not going to be just a bunch of toil for them to come go and do. That's interesting, right? So, the team has to mature enough. Now, they also have specific team sizes. That goes back to that on-call rotation, right? They need to make sure that, you want to make sure that there's enough people to spread out on call so that it's a reasonable load to take, that you're not going to be burning your people out. Because again, remember, we can't fire our way to reliability. People build systems. And so if we burn out our people, we're not going to build good systems. Now, that's Google. How many people here work for Google? All right. So, how you implement site reliability engineering can be slightly different probably because nobody else here is Google. Microsoft is not Google. Microsoft does things a little differently. Facebook is not Google. They do things a little bit differently, right? Google is Google, so Google does it their way. There's some other companies, though, that do site reliability engineering. This is a partial list of folks who are out there doing site reliability engineering, and you see companies all different sizes all around here. And how they go about it differs, and we're going to look at a couple of them. So, first one we'll look at is Facebook. At Facebook, they call them production engineers. But they are still, the practice that they are doing is site reliability engineering. So at the 2015 SRE Con, the guy who runs production engineering there, his name is, because I don't remember it right offhand, is Pedro, and I'm going to mispronounce his last name, so I'm not even going to call it, we're just going to call him Pedro. So Pedro was there to share what production engineering at Facebook does and how that really is site reliability engineering. So he shared their definition. Now we read Ben Trainor's definition a little before. This is going to read similar but a little bit different. So at Facebook, production engineers at Facebook are hybrid software and systems engineers who ensure that Facebook services run smoothly, capacity for future growth. They are embedded in every one of Facebook's product and infrastructure teams and are core participants in every significant engineering effort underway at the company. What is the key word in this definition? I heard it. Anybody else? Embedded, right? So how they go about, so at Google, they have separate site reliability engineering teams that are partnered with products. At Facebook, they're embedded in every one of Facebook's product and infrastructure teams. So it's a little different model. Remember I said your org structure can vary. Org structure is not the problem here. It's about alignment and goals. So how Facebook allocates their production engineering, it's about a 1 to 10 ratio. So one production engineer for about every 10 developers. They spend about 18, 24, or 36 months with a team, and then they rotate them through. They are not treated as like, you know, the SWAT team that kind of comes in and solves all the problems and then bolts out the door. Nor are they ticket monkeys, right? They're not there, hey, guess what? We got ourselves a production engineer. Here's the ticket queue, go nuts. That's not what happens. So at Facebook, you might have heard about their engineering boot camps. They also have a boot camp for their production engineers. It is an engineering discipline. That's one of the core things that we see about site reliability engineering. And remember how I said we have to come to an agreement about how we're going to behave about site service level objectives and whether or not that can like block deployments or how we're going to treat things. Well, one of the things that was really important to them at Facebook was that the lead of production engineering and the lead of product engineering report up to the same person. Not that we have these separate reporting chains that come up, and so when there is a conflict that is a significant conflict, it doesn't embroil the whole organization. It doesn't have to go to the CEO to decide whether the ops guys or the dev guys get their way. Right? It's all part of the same engineering org, and we can keep the same goals and incentives. Right? So we got another observation here, right? SRE requires high-level management support. Because we're talking about how we're going to operate our systems, and we're going to put things in place to either gate releases or put different focuses on how we're going to do work. splitting up some of that toil, right? Being able to push some workload perhaps onto other teams. That requires some management buy-in. This is not something that you're going to go and do as a grassroots effort all on its own. And if you try, it might not work so well. So let's look at another implementation here, Spotify. So Spotify, they're weird. I mean, they're cool, it's a cool service, but they're weird. So they have this really decentralized kind of environment. And it's sort of like Agile run amok. And they have these tribes and squads going out and doing things. And so, and there's even there's not like a centralized infrastructure team, except there sort of is. They just don't like being called that. It's kind of an interesting environment. There's no particular SRE org. However, they do have what they call ops and squads. So it's similar to Facebook in the fact that they have their site reliability engineering embedded in product teams. It's just a little more chaotic model. Now, one of the things they do is each tribe is responsible for shipping their features and their capabilities, and they don't have to use the same tooling as everybody else. But there is what they have. There is one of the things that they built called the golden path, and that's this proven way to get software into production. And if the team doesn't want to invest a bunch of effort in their own way to do it, they can adopt this golden path and move it forward. So that's kind of an interesting concept, and you see this in other environments and other ways. But one of the things that we should take away from how we're looking at these particular examples is that there's not really one right way to build an SRE team. There's not the one true way. Like, you don't go get the SRE book and then say, I've got to implement this exactly the way Google did, because that's probably not going to work right just for your organization, right? So there's no right way, but there are some wrong ways to go about it. And we're not going to delve too much into those, because if you get to ideas, you're going to end up going about it one of the right ways. So how do we get started? So number one, I mentioned I was going to show you some books. So there's a couple of books out there, Site Reliability Engineering. This is the one that kind of introduced a lot of the concepts on how Google does site reliability engineering. And then they came out later, very recently, with a workbook that has some of the more of the technical practices and concrete ways to do things. And last but not least, one of my teammates collected an anthology of essays around site reliability engineering from sessions and speakers that he saw at the various SRE cons. So David has the Seeking SRE. So these are a couple of books that are out there around site reliability engineering. Great place to start to kind of get that context. Don't start. And another thing is that there's SRECon events. Just like we've got our PowerShell Conf Asia here, there's actually an SRECon that was hosted here in Singapore earlier this year. There's also ones in Europe and in the Americas. So, but how do you go and start, right? How do you do this in your organization, or how do you bring this concept up? Now, I'm going to go through a couple of steps here, and then I'm going to go back and I'm going to change it up just a little bit. So, usually how this comes about is you have some sort of crisis. And whether it's an outage, or you read the book and now you're converted and you're going to come forth and like the good news of site reliability engineering across the organization and stomp out those evil DevOps people. No. So you come to some realization that you need something else. So you get your management support lined up. Do a little bit of reading. Hang out with some other SREs over at SRECon or at various DevOps days or wherever you find them. You start to dip your toe into service level objectives and error budgets. Now, my teammate David came up with this list. I think we might have some stuff that's out of order. So I would say you read the books. So before you can go pitch this to management, you kind of have to get some idea, right? You can read the books. I'm also going to point you to some other resources if you don't like to read. There's other ways that we can go about doing this. Hang out with some other SREs. Find out what people are doing in their environments. Talk to people, right? Hear what their problems and challenges are, and help and bring those into your ideas as well. Then you have your problem and downtime and epiphany and get one over, because now you've got some information to work with. Now you get your management support lined up. Now let's go back and do these things again, because now we have some more context. One of the challenges with, whether it's DevOps transformations, whether it's introducing site reliability engineering, whether it's any of these things, right, is we start out with this ideal of what we want to get to. Then there's this problem where that ideal hits reality. And now that ideal hit reality, and we actually see how some of that stuff bumps up, we can go back and look at these things again with fresh eyes and fresh context. And it's going to change how we think about this process. How I think about DevOps today is radically different than what I thought when I was working at a company that I just wanted to embrace DevOps so badly. Right? So then we get to dipping our toes into SLIs, SLOs, and error budgets. What I mean by that is start defining some of those things. Work with your partners in development and in other parts of the business to figure out what does running well look like, but not to necessarily gate releases or to do anything destructive, just to start visualizing that information. Get that monitoring dashboard up and available to people so they can start to see. It can be a scary thought if you're in an environment where we fire our way to reliability. Right? Because now we're going to surface information about how broken things are. But if we're going to have this conversation and we have that management support, so we're a little more comfortable with the idea of surfacing that information. We know we're not going to get fired for showing off how badly things are broken. Right? Once we start surfacing that information, now we can start seeing, hey, guess what? If we were fully implementing this pattern, we would stop deployments now because we'd dip below. We need to get our reliability indicators back up before we move forward on things. And you can start having those discussions and seeing what the actual impact of those type of changes would be in your environment. And then you can start looking at some of the other expanded practices from there. So this year at Ignite was the first year that we started talking about site reliability engineering, because guess what? Microsoft does site reliability engineering. What exactly does that mean across Microsoft? Who knows? Because there's a lot of different groups implementing it a lot of different ways. We're figuring that out. So if this is something that's interesting to you, it's a journey you can come along with